today we'll be looking at frictional force. In the last class, we focused on normal force as well as weight. We said that weight is the gravity on the body, and we said that normal force is the perpendicular force acting on the body, and it's exerted upward in the upward direction opposite to this. We draw a free body diagram to show that if this is the body, the normal force acts upward and then the weight acts downward. For today, we want to look at all the forces that can be generated in the system. We'll focus on frictional force. Well, frictional force is a force that opposes motion between two surfaces. It causes wear and it causes heat. But for today, the first thing I want us to take note of is the fact that for frictional force to act, there must be two surfaces. There must be two surfaces. In this case, we have the block. Then we have the support. So this is the support. So the interface between the two. Let's change the virus so that we make the difference clear. So there is an interface between these two. So this is the block, and then this is the support. Now, these are the two surfaces. Another thing you have to note is that as much as we are talking about frictional force, the two surfaces must either be in motion or about to move. Now, it therefore means that the block or one of the surface must be sliding or just about to slide. About to slide. So, if these are two ice blocks, so that this block is an ice block, the support is an ice block, there is no friction. So, friction only exists when the surfaces are rough. If the surface is rough, then friction exists. If the two surfaces are smooth, no friction. So, another thing you have to note is that frictional force exists when the two surfaces are rough. That's when frictional force exists. Now, we want to apply a force on this block such that the force moves this block in this direction. If the force moves this block in this direction, let's call that force an applied force P. Friction is that force that acts in opposition to the direction of motion. So frictional force will tend to act backward. It will act backwards to the direction of motion, and so this is your frictional force F. However, I want to describe two types of friction. We have static friction, and then we have dynamic friction. Static friction exists when this block is just about to slide. About to slide. Whereas dynamic friction exists during sliding. During sliding. First, we said friction exists where the surfaces are rough. Two surfaces must exist, and then one of the surfaces must be sliding against the other one. Now, two types of friction is existing. If the direction of application of force is towards the positive x-axis, then friction will certainly be acting towards the negative x-axis, so that it opposes the motion of the applied force. Take note of this, that no matter the direction of the applied force, the weight of the body always acts and the normal reaction always exists. So whether you apply force in any direction you like at all, the weight is there and then the normal reaction. However, for frictional force, there are two of them: static friction, when the body is just about to slide, and dynamic friction, when the body is sliding. Now, what is the relationship between the applied force and the frictional force? But before that, let's look at the relationship between the weight and the normal reaction. In the last class, we saw that weight is equal to the normal reaction, so that we agree that weight is equals to mg. Now, we want to look at what is happening at this interface between the block and the support. For static friction, there is a degree of resistance that this support is having on this block. And that degree of resistance is what is called the coefficient of static friction. I'll take that again. We remember that in the previous class, weight is equals to normal reaction and is equals to mg. When this block is just about to slide, we have what we call coefficients of static friction. Coefficient of static friction, denoted by mu s. This is coefficient of static friction. It's a frictional force that acts when the body is just about to slide. Now, when the body is sliding, we have what we call the coefficient of dynamic friction. Dynamic friction, which is always represented as mu k. Now, this k means kinetic. It's either you call it dynamic friction, sliding friction, or kinetic friction. Let's look at the free body diagram for these forces here. The normal force acts upward, the weight acts downward, frictional force acts this direction, and then the applied force acts in this direction. Now, this is a free body diagram for these forces. This is the normal reaction, the weight, the applied force, and then the frictional force. One of the principles of solid friction is that the normal reaction is always, as a matter of fact, proportional, directly proportional to the applied, to the frictional force rather. So by that principle, it means that frictional force F is directly proportional to the normal reaction, which we know as normal force, which is equals to what? Mg, by the principle in the previous class. Now, for us to replace this proportionality sign with equality sign, it implies that frictional force is equal to, for sliding friction, the constant of proportionality becomes the coefficient of kinetic friction times mg. I'll take that again because it's quite important. Remember that one of the principles of solid friction is that the frictional force is directly proportional to the normal reaction. And in the previous class, we established that normal reaction, weight is equals to normal reaction, so that we say that normal reaction is also equals to mass times acceleration due to gravity. Now, applying that here, we are saying therefore that the frictional force is proportional to the normal reaction mg. This implies that frictional force is equal to mu k mg. This is the coefficient of dynamic friction, or coefficient of kinetic friction, times mass times acceleration due to gravity for the frictional force. Now, if the body is static, about to slide, we say that frictional force is equal to the coefficient of static friction, mass times acceleration due to gravity. Now, I think this is where we're going to stop today. In the next class, we will build on all this to see how we can take calculations on this topic. Do not forget to subscribe.